Welcome back to our channel. Okay, physics paper 3, option C, imaging question 14, a very short question. First, A and B are a little bit related. This outline how dispersion affects the transmission of light in the optic fiber. Remember, in optic fiber, before the pulse is very sharp, high amplitude, but later on, due to the difference of speed or path inside the optic fiber, it will spread out. The time will be different. Okay. So when this spread out, the amplitude drops, okay? When the amplitude drops to such a low level, it is amplification again. So due to this extra amplification time, so the transmission of light in optical fiber will be lowered by the dispersion. So how to say it? Okay, I recommend say it in this way, just a suggestion. You can use your word to say it, okay? Dispersion makes the amplitude drops. When amplitude drops to a low level, extra amplification is needed. So what's the problem of amplification? Because when you do amplification, just extra time is needed. The transmission speed is lowered. There will be a bigger time lag when you do so. Next one, B, is a very hard. I'm a little bit confused about what's the solution. So if you have any suggestion, please comment down there. Maybe I can have some reflection on it. It says that 10 kilometer of optics fiber, they have different refractive index. So it gives me an idea. So remember the speed in the medium are different. So one you see over different n. Okay. So before the pulse is 1.0 nanon second, so it is 1.0 as first. Okay. So after going through it, what is the minimum received pulse duration? So just discuss about this difference of speed. So the lights will have different speed along the optic fiber, so they took different time to travel this 10 kilometer of distance. So remember, okay, T equal distance over V. So they have different V, right? So just copy the data. So D is a 10 kilometer. Okay, B is a C over N. C is a V times 10 to the power 8. So they have different speed. So they have a change of spread out of the time. Okay, the slowest one is this one, right? So copy correct 1.452998. Okay, it is the slowest one, so the longer time, right? So minus the faster time. Do the same thing again. V over n again, but this time you use the smaller n. So 1.45264. Complicated calculation. So you calculate this thing out and then you find out the difference, the spread out of the time, the duration. Give yourself some time. You really need to do it. So bring out your calculator, plug in. Well, then that's it, okay? So the time you got is 11.3 nanosecond. So before is 1 spread out, so add on, okay? So you can say minimum duration. Remember, always get it worse, okay? So add together 1.0 times 11 over 3, so it is 12.3 nanosecond. I think the term minimum means that they may have other reason for this dispersion, so the minimum one is here if it gets the other kinds of dispersion, okay? about the path or whatever. So this is my little suggestion. If you have any comment, please write down there. I will reflect on it. Okay. Thank you guys.